pretty much anyone who's listening to this is like probably well aware that Nvidia has been this incredibly successful company. Why have these like GPUs like from Nvidia been so successful over the last decade?
Yeah, there's a lot of reasons. First of all, let's go back a little bit in time, and let's talk about why CPUs became successful. The company Intel, most people have heard of. Intel originally was a memory company, and they begrudgingly switched to CPUs. And CPUs became a much better moneymaker. And the reason is CPUs fit into, they're not a standard. And so switching costs are higher. And it has all of the, if you've ever heard of the framework from Hamilton Helmer called 7 powers.
Yeah.
CPUs are like the personification of that. And then you see Intel, even with the Intel Inside going branding, all this other stuff.
Because they were both harder to copy, not a commodity like the memory.
You couldn't swap
types of things.
Yeah,
AMD had a x86 chip that was, I think, pretty similar, right? But was it just because it was just like it cost $2 billion to create a plant to go do, or what was the reasoning why the power was so high for like an Intel?
Well, with AMD, so there's another aspect here, which is when you're putting a chip when you're deploying a chip, it's not the cost of the chip that matters, it's the cost of all the infrastructure. So if you can increase the performance of a chip, the CPU, 15%, that effectively gives you 15% more value of the power that you're sending in, of the concrete in the data center floor, of the racks, of every single part of it gets 15% more economical. And so that means that a small performance advantage makes an absolutely huge difference in terms of your outcomes. And what you would see is a lot of the data center providers would build a system with AMD chips just to try and price negotiate with Intel with no intention of ever deploying them at volume.
Because the Intel chips were, even though the AMDs weren't really copies, the Intel chips were just better. They were priced higher, but they were better.
Correct. And this was a strength leads to strength kind of thing. When you pulled ahead, you got an advantage. But there was also a double-sided market because you would write code for x86, and then people would buy x86 systems to run that code. And then there was all these bugs in x86, and that became a feature because eventually all the software had to support these weird bugs, and AMD had to copy the bugs of Intel. And
yeah, totally. Okay.
There were literally people who were experts in the bugs in x86 just to make sure that people could make copies efficiently. Now, with NVIDIA, what NVIDIA did very well was there's probably at least 2 major things, but then there's a bunch of other things around it. The first was CUDA was a double-sided market, very much in the same way, because there's no known algorithm today to automatically compile stuff down to GPUs.
Not everyone listening to this probably understands what CUDA is. So can you explain it for a relatively smart person?
So there's what CUDA is advertised as, and then there's what it really is.
Okay.
So CUDA is advertised as the development platform that you use to write code for NVIDIA chips. That is trivial to replicate. That has basically zero value. You've seen one.
I didn't realize that. So anyone could just create a new something else to go do that.
Yeah, that's the easiest thing in the world. In fact, this is one of the things that eroded the x86 Intel dominance was things like .NET, LLVM, Java, which sort of Java was a little more brute force. You had to get people to target it.
Yeah.
But these other things, your C++ would compile to it, and all of a sudden the switching costs went down in the Hamilton.
Yeah, because it would work with anything. Okay.
Yeah. but the same is true of like the actual CUDA programming languages. Those are trivial to re-implement. The hard part is what's called CUDA kernels. And what a CUDA kernel is if I write a program, like let's say I create a video game.
Yeah.
And I want that to run well on a GPU. The problem with that is there is no known algorithm to take that code and to get it to work on a multi-core system efficiently. So human beings write these kernels based on the code that you wrote. So if you're a major video game design studio, you send your game over to NVIDIA and they will write some kernels, and then they're in the driver. And when someone loads up that video game, it runs faster. It's just like someone writing assembly to make a C++ program run faster. Now, this is needed because of the multi-core nature. And this is viewed as a huge advantage by NVIDIA. And when we did TensorFlow at Google, we ourselves had to write the kernels for NVIDIA's GPUs. Otherwise, TensorFlow wouldn't have been relevant.
Yep.
And so it's got this double-sided market feeling to it that makes it almost impenetrable. And so that's one. The second is that NVIDIA has forward integrated beyond what most people have noticed. So typically, most companies, they'll build a chip, they'll build a system, they'll build networking, they'll do some software. They don't do all of them. And what NVIDIA did was they started with the GPU and CUDA, so the software, whereas AMD was more letting other people write the software for them. And then they added a system, the whole DGX boxes. Then they bought Mellanox to bring in networking.
Yep.
And now they're doing their own cloud to compete directly with their customers, right? And that's the thing. They've always forward integrated. So there was actually a recent, I forget which company it was. There was a company that made NVIDIA graphic cards for a very long time. 80% of their revenue or some large number like that came from selling NVIDIA cards. And one day they just announced, we're done. We give up. NVIDIA has made it impossible for us. They've squeezed out all of our margin. They make their own cards. We give up. Even though it's 80% of our business, we're leaving it. And so what they do is they just forward integrate. And every time they get something established, then they start forward integrating into the next part.
But they still are a big like TSMC customer.
Yeah, absolutely. And that would be going the other way. They tend to forward integrate. They don't tend to go back into their vendors, right?
Yeah.
They take what their customers do and they do that themselves. And that and there's a reason why they go that direction rather than the other direction, which is there's more margin the more up the stack you go.
Yeah.
And they're trying to capture more and more of that margin for themselves.
Yeah. Instead of like selling NVIDIA systems to other people who then rent them out, they could just rent them out themselves.
Yeah, I mean, that's what they're starting to do. And they just announced an inference service. So they're even going to go beyond that and start selling, I guess, token as a service and compete with all their token as a service customers. So, when you get to that level of power, people can't really say, hey, I'm going to drop you because you're going to compete with me. They're like, I have no choice. I got to keep buying this. And every dollar that they send to NVIDIA is just used to develop more R&D to replace them.